last speaker this morning is Roberto Navigli. He works at the Sapienza, University of Rome, where he also at earlier times got his PhD. Roberto got two very prestigious European Research Council grants, a starting grant and a consolidator grant. We had the pleasure to work together on a Google award, on a Google-focused award, and he is very much known by bringing to this world a terrific resource that actually bridges a little bit the gap between lexical meaning and concepts in a way, in a very multilingual fashion. And I guess you will talk about Babelnet, huh?
Not only.
Not only, mainly probably about the role of disambiguation, right? About lexical disambiguation in AI. Okay.
Thanks. Well, I'm mentioning some of the joint work with several PhD students and postdocs and colleagues. So these are the names. I will not name them all because I'm between you and lunch, so I guess I have to be quick. But let's look at this sentence. This is, I think this sentence will let us really very easily understand why we need natural language understanding, why we need a machine to really understand and not just process text as a sequence of tokens. Is it healthy to drink from a copper vessel? I ask in English. Then I get a translation into Italian, and I'm also showing the translation, the translation back to English so that you can understand what's going on. And we get, is it healthy to drink from a copper ship? I mean, normally you don't do that, right? And so in Italian, it's è salutare bere da una nave di rame. So this doesn't make any sense. And why would a state-of-the-art machine translation system today translate this sentence like this? Because it's not understanding what's written in the text. It's not using knowledge to provide a better translation. And so let's put ourselves in the computer's shoes. And so if we don't read Chinese and we look at this, we don't understand a single word, a single character actually. Why? Because we cannot associate meaning with the characters, with the symbols. And so there are three main tasks that in natural language processing aim at enabling understanding in a machine. The first one is word sense disambiguation, which aims at associating meanings with words which occur in a given context. In this case, you have a sentence, you have a set of content words like nouns, verbs, and so on, and the machine has to associate the most appropriate meaning with the words that occur in context. The second one is semantic role labeling. With semantic role labeling, you move from the lexical level to the sentence level because you have to identify the key predicates that are normally verbs and the arguments that are part of the event described by the verb. And so you have to annotate, for example, in this case, fire with the firing event, let's call it the firing event, and identify a number of roles in the sentence like the employer, the employee, the position, and so on. Unfortunately, this is a previously state-of-the-art system that identifies the firing event as the shooting projectile event, which is not ideal if you have to fire an employee. That's not what you're going to do. And again, that's because the machine doesn't really understand what's written in the sentence. And so the machine thinks that we have to kill the employees to fire them, which is not what we want to do. Never do it. So the third level is called semantic parsing. So that's probably the most complex and most well-structured task in the sense that you want to transform the sentence into a structured form, like a graph, a tree, that describes the event or the set of events that are contained, that are expressed in the sentence. And so a key goal of AI is machine reading. That is the ability for the machine to read text and understand and transform the text into a structured form that can be an explanation for what the machine understood. And ideally, we would like to do this multilingually. I've been doing a multilingual NLP for many years now, and I'm very interested in how difficult and how challenging it is to process text independently of the language it is written in. And I had the privilege to head 2 ERC grants, one on multilingual word sense disambiguation that I'm briefly mentioning in the first part of this talk, called Multi-Jedi. So we moved from science fiction, and then I had the privilege to head another grant that is ongoing now. So we moved to desserts, because the other project is called Mousse. And so this other project is not about gastronomy, but it's about a higher level of semantics, multilingual semantics. That is, we move from the word level to the sentence level. And now, briefly, I'm talking about word sense disambiguation, and in the last part of the talk about what to do next. So we said that word sense disambiguation is the task of automatically associating meanings with words occurring in a given context. So we have the mouse is eating the cheese, and we want to choose the right meaning of mouse, which could be, in this case, is the animal meaning, but it could be the computer mouse meaning. So in this context, we expect the machine to choose the right meaning, and this is what happens, luckily. How do we do this? We need an inventory of the meanings that the machine can choose from. And so a standard inventory that is used in word sense disambiguation is WordNet, which is more than just a dictionary. It's a computational lexicon of English. It can be viewed as a semantic network, or today a lexicalized knowledge graph. And here you have meanings expressed as sets of synonyms called synsets, like, for example, car, motor car, automobile, and relations that connect synsets, like, for example, between a car and a motor vehicle, like a hypernymy is a relation between the two. And so this resource can be used first as an inventory, and second as a knowledge base to perform the word sense disambiguation task. However, this limits us to English. And there are many, many resources around, many in electronic format, others in paper form, unfortunately. But many of these resources are just like islands, so they don't talk to each other, are not interconnected. And this is an issue that we addressed in the first ERC project by creating this new resource called Babelnet, that is now 9-10 years old, but it's still alive and a lifelong project, because it requires a lot of work to be continued. So it's a merger of resources in different languages with the main objective to create a multilingual sense inventory. So if you want to scale from English to hundreds of languages, you need an inventory that can move from one language to another, while at the same time keeping the underlying semantics as common, as shared as possible across languages. And so we integrated WordNet, multilingual WordNets, Wiktionary, Wikidata, Wikipedia, and many other resources. And this was done automatically first, and then with some manual curation that is ongoing. And as a result of this, you have a multilingual dictionary. Like, you can query in a given word, with a given word in a given language, and obtain the meanings, including the synonyms that are used to express that meaning in a given language. But then you can view the translations of this meaning in other languages. You can view definitions and many other information. You have pictures, which is innovative in itself, because most dictionaries don't show pictures. And for example, here you're looking at a single entry, a single meaning of run in English as a verb, and you can view translations into dozens of languages. Ideally, here I should click video of a small portion of Babelnet that you can explore on the website, and that makes it possible to see that a dictionary nowadays is not just a dictionary. It's a graph structure, it's a semantic network, it's a knowledge graph where each node in the network can be lexicalized in different ways, in different languages, or within the same language in different ways with different synonyms. And this concept has connections to other concepts. And now, for example, we are looking at the same path in a different language. But it's the same underlying graph. So it's not based on the individual language we're looking at. So it's semantic, so it's independent of the language. And so currently it covers 284 languages, and it brings together concepts and named entities. So you can connect a Ferrari Testarossa as a named entity to the general concept of car, for example. This is well, in NLP, a well-known project, but it's also gaining popularity across other fields, and it was covered by several newspapers and journals. But let's go back to the issue of natural language understanding. So what are the current limits for machines to really understand what's written in a text? So the first one is a lack of high-quality knowledge. Unfortunately, the knowledge that is available is limited to resources like WordNet, even Babelnet, which is a huge resource, but still limited in a number of senses. Also, much of the word sense disambiguation research is limited to one language. And we also have low performance. So word sense disambiguation is ideal, we said, but it tends to perform low. So like when I was doing my PhD, the state of the art was 65% accuracy, which means that the system would understand 65 words out of 100. So what can you understand? Nothing. So we wanted to move on. And so to improve this, all these points. And so what are the key ways to address this task? There are two main directions. One is using today a neural approach, like an LSTM, a transformer architecture, which aims at learning how to tag words with senses, with meanings. The problem with this approach is that there's not enough data. So while there is a variety of data sets for many other tasks, as you move to the semantic task, you need to provide millions of items annotated because you have hundreds of thousands of words, and for each of them you have to provide examples. So this approach performs well, but has the issue that there's virtually no data for non-English languages. The other approach is knowledge-based. So the knowledge-based approach instead has the plus that you don't need manually annotated data. You just need a general resource like a lexical knowledge base, like WordNet, like Babelnet, and so on. The minus is that it tends to perform lower than the best supervised approaches. But we'll now see that there are ways to actually rival and even beat supervised approaches, and while at the same time scaling to any number of languages. So let's focus on the first issue, the lack of high-quality knowledge. What do I mean by this? I mean that we have these resources. We have computational lexicons, WordNet primarily. It's manually curated, and it tends to encode what are called paradigmatic relations, like vertical relations, is-a relations, like a car is a motor vehicle, a convertible car is a car. So this information can be used by a system, but it's not really ideal when you want to disambiguate, because in many cases when you disambiguate, you have what is called syntagmatic relations, because these are the relations that tend to connect words that co-occur in a sentence. Babelnet is much richer, contains a huge number of unclassified relations, like, I don't know, the EurASc connected to Brussels, the screen connected to Pixel. We don't know which kind of relation it is. And so to disambiguate well, we actually need quality syntagmatic relations. So we need those kinds of relations that are called, at the lexical level, collocations, like bus driver, open door, open business, play piano, and so on. And so, however, these are just words. We need to identify the right meanings that actually connect pairs of these words. Like, for example, when I say play piano, I don't mean I don't imply the same meaning of piano as when I say play act or play game. So these are different meanings that have to be disambiguated. And so we asked linguists to perform this task for us. And actually, in my group, I hired linguists to perform this task and provide syntagmatic information tens of thousands of relations, lexical semantic combinations, collocations, that could be added to lexical knowledge bases like WordNet or Babelnet. So for example, here you see a lot of taxonomical information, but you don't see many horizontal relations like of a syntagmatic kind. While what we did was to add these kinds of relations. Like if I add a relation between car and drive or between pilot and aircraft, then if I use an algorithm that exploits the structure of the graph, I can transfer this information. I can infer many more relations that are missing in the graph but can be induced as a result of traversing the graph. And the advantage of this is that these are semantic relations and they are multilingual by design because the items, the nodes that are connected are multilingual coming from Babelnet. And so a very simple algorithm that can be used to perform knowledge-based word sense disambiguation is the personalized PageRank algorithm, which is based on Markov chains. So here, if we have a single word in a given context to be disambiguated, and we have a number of words that are that make up the context of the sentence, we apply an algorithm that virtually is like performing millions of random walks and identifying the meaning of the target word that is at easiest reach given the other meanings of the co-occurring words. And so if you have these bridges, this syntagmatic information, then what we can prove is that the quality of the disambiguation is as good as a supervised system. What we did was to add almost 90,000 relation instances from a resource that we are going to present at EMNLP in November in a couple of weeks. So SyntagNet contains these 90,000 relations that bridge the gap between concepts that are not connected in WordNet or Babelnet. And the only take-home message of this picture here, of this table, is that if you use a supervised approach, a state-of-the-art neural word sense disambiguation system, you obtain virtually the same performance as a knowledge-based system that is not trained on the task, that is not using sense annotated text, and that is exploiting a general lexical knowledge base, but now with additional information. So you're achieving 71.5% accuracy across several data sets. But this is on English. If you now move on to other languages where you don't have the supervision, you don't have examples to train your system, your neural system on, the neural system lags behind. And actually, the knowledge-based system can still perform with almost the same performance as with English. So this is the result we were interested in. And this proves that actually doing like a simple exercise, like adding syntagmatic relations to a knowledge base, a multilingual knowledge base, can rival supervised word sense disambiguation with state-of-the-art approaches. Now, the second point is low performance and being limited to one language. So we want to overcome the language barriers. And what is the solution? Moving from the lexical level to the semantic level. And so much of the research in NLP is done with the so-called word embeddings or sentence embeddings. So the word embeddings don't encode any explicit semantics of the various meanings of a given word. They implicitly conflate all the semantics that an ambiguous word can express. So if I have an ambiguous word, a single vector is used to represent the whole semantics of all the meanings of this word. If we move to a semantic vector space model that encodes senses rather than words, so the vectors here are senses rather than words, then you can scale. You can scale multilingually and you can improve the performance. And so what we did was to provide semantic representations for each sense of a given word by exploiting the latest transformer architecture-based sentence embeddings, BERT and the subsequent approaches of this kind to create a latent representation of a single meaning of a word. And so now we have a very rich implicit latent representation of a given sense. And if we exploit this in a very simple way by comparing a given context for which we don't know the right meaning of a target word, and we compare this representation of the sentence, like a sentence encoding, targeting a certain ambiguous word, like for example, if we have the word mouse again, we take a sentence that we want to disambiguate, like for example, here we have the mouse is eating the cheese again. So we have this sentence, and we want to disambiguate this sentence. We represent the sentence as a vector using BERT and a contextualized embedding. And then, because we have also a semantic vector in the same space for each sense of the target word, so one for the animal meaning of mouse, one for the computer mouse meaning, we just use one NN, one nearest neighbor. What is the closest sense of mouse to that sentence? And we disambiguate the sentence. So it's very easy, very powerful, and the performance is 80%. So if we do this without any supervision, just using the knowledge base, we obtain 75.7% overall accuracy, which is very high compared to the other results that we just looked at. If we add annotations from corpora, then we obtain 80.5% accuracy, which is the best result currently in the literature, and which takes us to the next stage. How do we move now from this 80% to something more interesting that makes disambiguation and understanding more useful? And I have 1 or 2 minutes only to do this, unfortunately. So briefly, I spent most of my time talking about this multi-Jedi project that is over now, and that led to the creation of Babelnet and multilingual word sense disambiguation. But now we are working on a higher level. So how to create structures, semantic structures that are multilingual, that are independent of the language, and that can be used to encode sentences and text in arbitrary languages, and then to perform semantic parsing. And so I have 2 slides only to show this. So what you want to do, as also Professor Hajic mentioned, you have a sentence, you focus on a given verb, like eating here. Yes, I know. You have the eat verb here, and you want to identify the right roles, the right arguments in the sentence at the semantic level that are connected by the verb. So eating has 2 arguments here, the mouse and the cheese. But here you don't have all the information that you need in order to scale multilingually and to move to the semantic level. Why? Because while the resources that are currently available tend to be language specific. So you have one resource for English, one for Czech, one for other languages. There are some connections, but they don't scale to many languages. And so what we did was to create a new resource called Verb Atlas that provides a framework and also all the information covering all the verb meanings that are available that can be expressed in most languages at a level that is independent of the language, while at the same time being bound to individual languages. So you can use this resource for labeling, for semantic role labeling, for identifying the roles and disambiguating the verb in the sentence, but at the same time, you can this representation will be independent of the language. So you can compare your representation from English to mine from Italian, and so on. And you can achieve 90% semantic role labeling performance, which is an interesting figure and is the state of the art currently, while being language independent. If you have questions on this, I'm happy to answer your questions. And finally, 1 slide about Babelscape. That is a company that I was kind of forced to create because of a number of requests about all the outcomes from my research group. It's very interesting to see that if you do a lot of research that scales, that allows companies to scale across languages, companies will come to you and will tell you, you have to create a company, you know? And I didn't realize that, so we did that. And now we are working with the EU Intellectual Property Office and many big companies. We're also involved in a new project. And two things that the company is doing is, for example, to take a document, transform it into a language-independent knowledge graph. And so these are two knowledge graphs created from two different documents, but they are almost the same. So even if they are written in two different languages, so we can compare the documents across languages or understand what is the meaning in a given document. Or we have services like this My Knowledge Graph that takes a text or takes a terminology and transforms these texts or these terminologies into knowledge graphs that are multilingual by design, by just starting from a single language and moving to any number of languages. So in conclusion, the aim of this talk was to give a brief overview of what can be done today in order to enable natural language understanding across languages, and how to scale in a way that the representation is not bound to the language from which the machine worked on. And what I advocate for is the interaction of linguists, because many of these resources, as was also mentioned earlier, need linguists to create the underlying connections between the lexical and the semantic level. And so, for example, Verb Atlas and improvements of Babelnet need to be manually curated. But at the same time, I also advocate for this integration of symbolic and sub-symbolic techniques. This was also mentioned earlier, and I truly believe in this. So knowledge-based techniques can work together with the neural state-of-the-art approaches to achieve the state-of-the-art, and at the same time provide explanations for the output that has been produced by the system. And so the system is now more understandable, explainable, and scalable, and can even further improve its performances. And this is also thanks to scaling across languages, given the existence of a multilingual sense inventory like Babelnet. That is all. Thanks, or merci.
Thank you. And we caught up a little of time, so we have time for questions to Roberto.
What is the level of effort needed to establish these manually curated resources?
For example, Verb Atlas. Actually, if you starting from Babelnet, which is an initially fully automatic approach. So we created an algorithm for linking the various dictionaries and resources fully automatically. After this, and after some validation that is not so intensive, but still keeps some errors and mistakes in the resource that are acceptable, when you move from the lexical to the sentence level, like for example with this Verb Atlas resource that we are going to present at the MNLP, you need an effort because you're scaling from one language to the semantic level. You need to work on the set of concepts that are available, for example, at the verbal level. The amount of effort to create such a resource, a first version of this resource that we're going to release, is a couple of years of work of one linguist, or if you have more linguists, let's say between 1 and 2 years of work. So it's not that much, but you can create a resource that allows you to scale across languages because it builds upon other multilingual resources. Otherwise, you need to work much harder, because you have to work on a single language, on the set of synonyms, so all the things that are available, you have to rework on them from scratch for each and every language.
Well, one idea that people have heard over the years is using various methods of crowdsourcing things to get a lot of things, right? You use CAPTCHA, and at the same time you're doing your training images. People play games, and you're collecting them. And I wonder whether such approaches are applicable here as well.
Well, I tried crowdsourcing a lot, also gamification. And I must say that when you want very high quality and you want a certain underlying homogeneity and consistency, my take is that crowdsourcing will not take you there. So at least you will need much more work on top of that, because I don't believe in a high-quality resource created just by crowdsourcing. It can be a good basis, though.
Thank you. There's one question and then
Thank you. Not being a linguist or an AI person and being linguistically challenged, I have a following question, more of some general questions about AI and modeling human intelligence and what that means and whether that's necessarily good or bad. But in terms of your approach, and I can only comment upon English, and that is that you have a moving target, because even if the formal academies and organizations charged in each country with changes to the language officially, your crowdsourcing, if you like, population is doing something completely different. So in English, clearly I think, and I'm open to dispute here, the rules of grammar, which are already somewhat limited, are diminishing with time in the popular use.
Not only in English.
The vocabulary is certainly expanding to include kofefe and other intelligent utterances from leaders. And if you go, one of you had a slide that said you could take data from the web. You could search the entire web as a database. But if you type any word in English misspelled into the web, you will get numerous examples of its misuse, right? So how do you approach the degree of misinformation or the speed at which things are changing in the general use?
Yeah, so it's really a very relevant question. There are many aspects that I don't have the time to discuss, but I'll give you two short answers. One is on the resource side, we are keeping Babelnet alive. So there's a live project that gets all the information on a daily basis from the sources it feeds on. And so if a new entry is added to Wiktionary or to any of the resources, this is included in Babelnet. Of course, this is not enough, and also all the misspellings and all the new uses of languages are missed in a sense. However, that's where the sub-symbolic approaches chime in, because then you can really exploit the fuzziness and the ability to generalize and to scale of neuro approaches. So I think that's where you want to process, to associate a word that you don't have in the dictionary with an entry in the dictionary.
Yeah, just a quick question. I mean, if I understood correctly your example about the firing, you characterize that essentially to explain why you need a much larger resource with better word embeddings. But actually, I wasn't completely convinced by that, because I think at the end of the day, if you really want to cover all the firing situations, at the end of the day, you need word models. You can just you need the background knowledge bases. You can just do it with word embeddings. So, for example, like if I'm reading The Godfather and they say where they fired whatever Peluso. That means that they fire, because that's the way the way the mafia fires employees is by killing them. So that's a very different semantics from normal firing in a software organization. So of course, funny enough, you were actually giving that as an example. So essentially, the point is that I may have a little bit misunderstood, but it seems to me that you were using that example to emphasize the need for larger scale, better resources for word embeddings. But still, I will say that in a lot of cases like that, and many other examples, the word embeddings are not enough, because you still need additional mechanisms to understand the context in which that particular sentence and the real meaning of the words in a particular context.
Yeah, so I agree. However, what I'm also advocating for is that if you move from word embeddings to sense embeddings, and you exploit the contextual information to encode this data, you will see enough examples of usage of the various meanings of that word, like the verb fire, so as to cover as many usages, as many examples as possible that you will not have seen, but you will be able to associate the right meaning with. So obviously, the machine will always make a mistake. Like also humans. I work with lots of linguists, and many linguists, unfortunately, make mistakes like all humans. And so what I mean is that if you encode provide a multilingual encoding and semantic-based encoding of a given meaning and not just the word, which is ambiguous, then your ability to solve those kinds of issues will be much stronger. That's the key point. It's not one word embedding, yeah, not anymore. And it's multilingual, so it's independent of the language, while the word embedding is specific to the language. So it has two advantages. So it's meaning-based and independent of the language.
Now we have to.
Thank you.
Thank you.
Thanks a lot.